All right, guys, so in these examples, we're going to be looking at how to rewrite our equations that are in standard form into slope-intercept form. Okay, so before we graph any linear equation, we want it in the form y equals mx plus b. We want to clearly be able to see our y-intercept, the b, and we want to clearly be able to see our slope, okay? So you cannot graph a linear equation in this form. Y must be alone before you can graph it, okay? So we're going to go about this using some of our solving techniques, and we're going to try to get y alone in this equation. So I'm going to draw my line to separate my two sides of the equation. And I'm going to go ahead and just highlight what I'm trying to get alone, right? So I'm trying to get this y all by itself. So in order to get y alone, I first want to move anything that's on the same side as y but not attached to y, right? So this 2y, I can't remove the 2 to the very end because those are attached by multiplication, but I can move the negative 3x to the other side by going ahead and adding 3x. So I'm going to add 3x here, and I'm going to go ahead and add 3x over here. So once I add 3x to both sides, this is going to cancel out. So now I'm left with 2y. And then these are not like terms. So don't combine this and say 13x because this doesn't have an x and this does have an x. And we want to write it in this mx plus b form, so I want to write the slope first. So I'm going to write the 3x, nothing in front of it because it's positive. And then I'm going to go ahead and write the 10, and since that's positive, I'm going to put a plus to connect them. Now again, trying to get this y all by itself. This is 2y, so that must mean that they're connected by multiplication. So the opposite of multiplication is division. Everything on this right-hand side is getting divided by 2. So this is going to cancel. So now I'm left with y equals. I'm going to leave my slope as a fraction because that's how we want to deal with our slope. That's how it's going to be easiest for us to plot our graph. So I'm going to leave this as 3x over 2, or 3/2 x. And then I can simplify the y-intercept. I don't want a fraction for my starting point. 10 divided by 2 is 5. Okay, so now that this equation is in the form that we want, we can go ahead and identify the key pieces so that we could graph this. So remember, b is our starting point. So our starting point is 5. That's our y-intercept. And our slope is whatever is in front of x. So that's that 3 over 2. So I'm going to go to 5 on the y-intercept. I'm going to plot that first. So I'm starting at the origin. 1, 2, 3, 4, 5. My slope is a positive 3 over a positive 2. Remember, the numerator tells us to either go up or down, and the denominator tells us to either go right or left. So since the 3 is positive, I'm going to go up. Since the 2 is positive, I'm going to go right. So up, 1, 2, 3, right, 2. Now I can't fit anymore, so I'm going to do what's equivalent to this in the other way, right? So if I rewrite this as negative 3 over negative 2, we know that a negative divided by a negative is a positive. So I could also use that slope, and that'll give me the points going the opposite direction. So with the negative 3 over negative 2, I'm going to go down 3, and I'm going to go left 2. So down 1, 2, 3, left 2. 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 Always plot as many points as you can. I'm going to go ahead and draw a line connecting all my points. Don't forget to put arrows to indicate that the line goes on forever. All right, let's go ahead and look at another example. So now I want to rewrite each of the following equations again in y equals ms plus b form. So we're going to go about this the same way. So I'm going to draw my line again. I'm going to highlight the variable I'm trying to get by itself, which is y. And I'm going to move everything away from the y. So again, can't touch the 2 because it's connected to the y by multiplication. I want to move this x to the other side. So the opposite of x is subtracting x. So x minus x is 0. This will cancel. So now I'm left with 2y. Again, I want to write the x term first because it's mx plus b. So first I have a negative x. And my 6 is positive, so it's getting a plus. Now I got to figure out what I got to do next to get y alone. Again, attach by multiplication, undo multiplication by division. Going to divide everything on this side by 2. So these 2's will cancel. I want to write my slope as a fraction, and I want to write it with numbers in the top and the bottom just so it's easier to understand. So hopefully remember that when we don't see a number in front of the x, the coefficient is secretly a 1. So I'm going to rewrite this as negative 1 over 2x, just so it'll be easier for me to graph. And I can simplify my y-intercept again. 6 divided by 2 is 3. So now that we have our equation with y alone, it's ready to be graphed. Let's go ahead again and identify some key features. So the y-intercept is 3. That's our starting point. And our slope is negative 1 over 2. So I'm going to go ahead to 3 on my y-intercept. Put my starting point. Now, if our slope is negative 1/2, I could rewrite that as negative 1 over 2, or that's the same thing as 1 over negative 2. It's just important that either the numerator or denominator are negative, not both, because remember, a negative divided by a negative is a positive. So if I use this first slope, remember the numerator tells me to go up or down, the denominator tells me to go right or left. Since it is a positive on the bottom and a negative on the top, for the negative up top, I'm going to go down. For the positive on the bottom, I'm going to go right. So I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Now I want to get points on the other side. So I'm going to use the other form of this. So if I'm using this slope, the 1 over negative 2, the positive 1 in the numerator is telling me to go up. The negative 2 in the denominator is telling me to go left. So I'm going to go up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. Draw a line connecting all my points. Put arrows at the end. Let's look at one more example. Again, same deal, trying to get y alone. Let's draw our line separating the two sides of our equation. Let's highlight our variable. Now, people tend to fall into a trap with a problem like this because they get into the habit of looking at the previous examples and being like, okay, I moved the x here, I moved the 3x over here, I must move the x to start over here. But notice that's not the case. The 5x is already on the right-hand side, so I don't want to be moving this, okay? I want to move everything away from y. So always make sure you kind of highlight and identify your variable first so you can see what you need to move away from it. So on the side with the y, I have the 3 which is attached, so I can't touch that to the end, but I have this minus 12. So the opposite of adding 12 is subtracting 12. So I'm going to minus 12 here and minus 12 on the other side. These will cancel. So now I'm left with 3y. Again, these are not like terms. Don't combine them. We're going to write this as 5x minus 12. Again, I'm going to highlight my variable. So what's attached to it now is this 3. I can undo the multiplication by 3 by dividing by 3. And I'm going to make sure I divide everything on the right-hand side by 3. So this will cancel. I'm left with y. My slope is already a nice fraction. I'm going to just recopy the 5/3 x. I can simplify my y-intercept. Negative 12 divided by 3 is negative 4. Now that y is alone, I'm ready to graph this equation. Going to identify the two key pieces. So my starting point is negative 4. My slope is 5/3. Let's go to the y-axis. Let's go to negative 4. Put a point. Now our slope is a positive 5 over a positive 3. So since it's a positive over a positive, I'm going to go up 5 and right 3. So up 1, 2, 3, 4, 5, right 1, 2, 3. Up 1, 2, 3, 4, 5, right 1, 2, 3. I can't do any more this way. Again, I could do the opposite, negative 5 over negative 3, because a negative divided by a negative is a positive. So I could go down 5 and left 3. So down 1, 2, 3, 4, 5, left 1, 2, 3. I plotted all the points that I could. I'm going to draw a line connecting them. And again, put arrows at the end. All right. One other thing that's good to get into the habit of is just to check your equation at the end. So my slope is a positive 5/3. If I were walking, I would be going uphill. Positive slope looks good. My previous example, my slope was a negative 1/2. My line should be going downhill. If I was walking, again, left to right, I would be going downhill. Looks good. Okay, final example that we had, the first one. Slope is positive 3/2. If I was walking, I'd be going uphill. So it's just good to get into the habit to check your graph to your slope at the end.